So as promised, here we are at the last section of Chapter 7. It's a pretty short one. They're called product to sum and sum to product formulas. They are a little tricky to use. They're very handy to remember that they exist, okay? But we really don't emphasize them too heavily in this course. They don't come up nearly as often in any applications as the sum and difference formulas. I'm not saying they never come up. They're not totally useless. But honestly, they come up pretty rarely, so the main point here is to know that they exist so that when you need them, you can go look them up. The objectives are pretty straightforward. So the sum to product formulas allow you to go back and forth between products of sines and cosines to sums of sines and cosines and vice versa. So for example, here are your product to sum formulas. If you have the sine of one angle times the sine of another angle, notice these are different angles. You can express this as the difference of the cosines of two related angles. Similarly, the cosine of alpha times the cosine of beta can be expressed as the sum of the same terms. And the sine of alpha times the cosine of beta, notice that this one now mixes a sine and a cosine, can be written like this. So clearing out my marks, I'm just going to justify the last one. You can imagine, once we see how this one is derived, you can see how the other ones are going to happen. So we know that the sine of alpha plus beta is sine alpha cos beta plus sine beta cos alpha. On the other hand, the sine of alpha minus beta, if you look at the difference formula for sine, is going to be sine alpha cos beta minus sine beta cos alpha. So what happens if I add these two things together? Well then, you get sine of alpha plus beta plus sine of alpha minus beta on the left, and on the right, these two terms cancel and you get 2 sine alpha cos beta. And now if I divide by 2, we get exactly this. So very similarly, if you use the sum and difference formulas for cosine, if you add these together, you'll end up with this term. If you take the difference, you'll end up with this term. And then you just have a factor of 2 that you divide out. So as we have seen in a lot of sections here, these new formulas are really just the sum and difference formulas for sine and cosine applied in specific ways, which really means those sum and difference formulas for sine and cosine are the most important ones to understand how to use. Okay, so can you express each of the following as a sum containing either only sines or only cosines? So for example, for the first one, okay, let's see exactly what the goal here is. If I use that first formula, the product to sum formula, I can replace the sine of alpha times the sine of beta, letting alpha equal 5 theta, and beta equals 3 theta. I'm just plugging them in, 1/2 cosine alpha minus beta minus cosine alpha plus beta. But now 5 theta minus 3 theta is just 2 theta, and 5 theta plus 3 theta is just 8 theta. So what we did is we took this expression involving a product of sines and rewrote it as something containing only cosines but not a product of different cosines. So how can you use the other formulas from the previous slide to do parts B and C? So I'm actually going to flash back to the previous slide so that we can copy these down if we need. Otherwise, just have them open on another screen, or if you have a physical book, open it to there. Otherwise, pause the video and copy these down. Okay, hopefully we copied them down. So use similar techniques as part A here to complete part B and C. So pause the video, work those out, and then let's see what we get. Okay, so for part B, cos 4 theta cos theta, that's a cosine times a cosine, so we use the middle formula. Just letting alpha be 4 theta and beta be theta and just plugging them in, that simplifies down to this. And now we do indeed have 2 separate cosines not being multiplied together. For C, it's going to be the last formula. It's the only one that has a mixture of a sine times a cosine. And again, alpha's, the angle in sine is 2 theta and the angle in cosine is 6 theta. So here's how that formula works out. And that simplifies down as follows. You could then use the odd property of sine to factor out that minus. I would consider that to be an optional step. But there we have it. Okay. There are also what are called sum to product. So the previous ones were products to sums. On the left hand, we had a sine times a sine or a cosine times a sine. And on the right, we had a sum or difference of different things. This is sort of the other way around. If you have sine alpha plus sine beta, and you would rather express it as the product, you can. If you had sine alpha minus sine beta, and you'd rather express it as a product, you can. And again, these are not really new formulas. These are just the old formulas with the variables slightly changed. Okay, so either open this on another screen or copy them down because we're about to do examples using them. And again, don't worry about memorizing them. No one memorizes these. I don't know anyone who ever has. On the other, but what you want to do is remember that they exist so that if you are ever looking at the sine of an angle plus the sine of a different angle, something in your mind says, would I rather take the sine and cosine of the average of the angles or the midpoint of the angles? That's what alpha plus beta over 2, that's the average, and alpha minus beta over 2, that's the midpoint. Would I rather take sines and cosines of those? Because maybe then I want to use this formula. So it relates the sine and or possibly cosine of two different angles to sines and cosines of their average and midpoint. So anyway, hopefully by now we've written these down. So let's use them. Take these sums and differences and express them as products using those formulas. So pause, work that out. It's just a matter of identifying which formula to use and then plugging things in appropriately. Okay, so let's take a look. So for part A, we're going to use the one that involved two separate sine terms and a difference specifically. So we just end up with 2 times the sine of the midpoint times the cosine of the average, which works out to just be 2 theta and 4 theta respectively. Maybe in some particular application that would be easier. Of course, observe one interesting thing that happened is that we started off with a sine of 2 theta and we ended up with a sine of 2 theta. That's really quite a coincidence in this problem. You would not expect that to happen in general. Okay, for part B, we're just looking for the one that has 2 different cosines added together, and that's formula 8. And just plugging in the various terms, we end up with the following, and there's not a lot we can do to simplify. Oops, there's not a lot we can do to simplify that down. So that's really all there is to this section. Don't stress about it. We hardly ever assign much out of this, and they don't really pop up on exams. The sum to product and product to sum formulas, you should just know that they exist and know how to use them, assuming they're written in front of you because you were able to look them up. But vastly more important are the original sum formula for sine and sum formula for cosine. A big theme over the last few sections was just starting with the sine of alpha plus beta equals sine alpha cos beta plus sine beta cos alpha, and similarly the formula for cosine of alpha plus beta is cos alpha cos beta minus sine alpha sine beta. Just starting from these two things here, we were able to derive a whole lot of other formulas, sometimes with the assistance of the Pythagorean identities mixed in, but basically starting here, we got everything else. So know these formulas. These are the ones you want to be very, very comfortable using. The half angle and double angle formulas are quite useful in certain applications in calculus, so pay some attention there if you're going to move on to Calc 1. The product to sum and sum to product formulas is more of a, know that they're there, but don't stress about it. Anyway, that was all of Chapter 7, so thumbs up, congratulations. On to Chapter 8.